This equation is problem 53 from Review Chapter 6. Once again, it's an equation that's a rational equation. It contains fractions. We want to get rid of the fractions. We need to pick a multiplier that will cancel as we multiply through. It will cancel all of the denominators. That multiplier would have to have a 3, so that when we multiply this term by 3 and this term by 3, the 3's would cancel. This term needs x squared in order to be able to cancel. So 3x squared is what I will have to use as my multiplier for each term of that equation. Multiplying each of these terms by that multiplier is the same as multiplying the entire side of that equation by that multiplier. And so I've multiplied both sides of the equation by 3x squared. Multiplying here, again, since this is a multiplication between the 3 and the x squared, then I can cancel. As long as it's a multiplication between them, I can cancel. And what's left is 2x squared. Here, the 3's will cancel. And x squared, remember, means you have two x's being multiplied. And won't this one down here cancel one of those two, leaving me one x that's there being multiplied? So I have 5x equals, the x squareds will cancel, that gives me 3. Now this is a quadratic equation. We know because the highest power of the variable is 2. Quadratic equations, we have a couple of different methods we can use to solve them. And generally it revolves around first putting the equation in standard form. So let's subtract 3 from both sides to put this quadratic equation into standard form. Now what I'd like to do is see if that's a factorable trinomial. If it should happen that it's not a factorable trinomial, I could then solve the quadratic equation using the quadratic formula. Remember, that always works for us. Well, we need a plus and a minus, because that's a minus 3. That would have to come from a plus, becomes a minus under the L of FOIL. I need to make minus 5. Well, I think I can do that if I put a 2x here, a 3 there, x there, and 1 there. The O of FOIL under this arrangement would give me minus 6x. The I of FOIL would give me plus 1x, and those two terms combine to minus 5x. And we have our factorization. And now remember, we look at what values of x could make this entire quantity become 0. Well, if this quantity became 0, that would be done if x was 3. 3 minus 3 would be 0. 0 times anything is 0. That's a solution because it makes the left side the same as the right side. And here, what value of x could make that quantity become 0? Well, remember, one way to find that is to set that factor equal to 0 and solve the resulting linear equation. We'll subtract 1 from both sides, divide both sides by 2. Our two solutions to the original equation are x equals negative 1/2, x equals 3. What was our restriction here? Well, the value of x that would make one of those denominators become 0 would have to be 0 itself. Neither of our solutions are the restriction. We can accept those solutions as being correct.